Production. Okay, so yeah, I have two goals today. The first goal is I want all of you to feel personally attacked by what I'm saying. And my second goal is to start a flame war. And so if I don't see a bunch of comments in the Crowder chat or get a bunch of annoying ats on Twitter, I will be very disappointed in all of you. So with that, let me dive in and talk about how to develop a bad research tool. So a quick outline for the talk. So first of all, this is all my opinion based on loads of experience that I have developing bad tools. So take whatever I have to say with a whole heaping pile of salt. This talk, I'm going to first give some advice on how to develop bad tools. And then, maybe I'll give some advice on actually how to develop good tools and some alternatives to those bad things that people do. And then I kind of want to wrap up by looking at this a little bit more broadly and think about what we can do as a community to try to encourage more good tool development. Okay, but before we get into it, let's define a couple of terms. So first of all, what is a tool? So I kind of consider whatever the software is that we're developing in order to do our research, or even hardware, other kinds of things that we create to do our research, this is a tool. So this could also be known as research infrastructure or research artifacts. Basically, it's whatever we used and developed to generate the data that we gathered in our evaluation of our research ideas. So in computer architecture, which I'm a computer architect, this is things like software simulators, software emulators, FPGA designs, which is also kind of software, and even like actual chips. These are tools that we're using in order to do our research. The PLOS part of ASPLOS, I guess they also have similar kinds of things, compilers or systems that are built to do research. And as systems engineers, systems researchers, these tools that we're building, this is where we spend most of our time. So I think it's really important to think about how to develop good tools. So what is a good tool? Again, my opinion, but I think that a good research tool is one that generates impact. Of course, now we need to define what is impact. And so one way we can define that is by citations. So this is like the current citation count of Gem 5 is in the 4,000s, which is kind of indicative of having some kind of impact on the community. Another way you can look at impact is if people build on top of what you've done. So either build on top of your research idea by leveraging your tool, or building on top of your tool to develop even better tools. This is what science is kind of all about. And then I think computing, and especially in systems, we have this other way to have impact, which is through tech transfer. So, if you really want to have impact on society, the way we can do it is by having companies pick up our ideas, our research ideas, or maybe even companies picking up our tools and then using that to profit and to affect society as a whole. So with that, after you've defined tools and what a good tool is, let's now see how to develop a bad tool. I'm going to give you a few tips and tricks. Step 1, create an in-house tool. Because your research idea that you've had, it's good enough to have impact on its own. There's no need to give any kind of tool for other people to use what you've come up with. Plus, others can easily build on top of your idea. There's plenty of information in the paper. It's super simple to recreate all those details that you had to create in order to get your research idea out there. Not to mention, funders love to fund someone else to recreate all the infrastructure necessary in order to compare to your idea. Let's face it, there's no reason for anyone to reproduce your results anyway. Like, why wouldn't they trust the numbers in your paper? You've never made any mistakes yourself. And most importantly, keeping the tool in-house gives you a competitive advantage. And what is research but a competition? Not to mention it's a zero-sum game. If another group publishes that paper before you, there's no way you can do what you were planning on doing. And what is science about but about winning? So step number 2, don't follow software engineering best practices. No one's going to see your code anyway. You're keeping it in-house. It's okay that the code is ugly. And research quality code, that's the mark of good code, right? And doing things like having a monolithic design, the more coupling you have between your software, the better it is. Who needs version control? You've never made a mistake in your life. Your hard drive's never going to die. You're never going to have to roll back to some previous version. No problem. Why would you write tests or validate? Again, you're a perfect coder. And even if you do find a bug in your code, you've squashed that bug. You're never going to need to squash that bug again. It'll never crop up. When you're developing models, again, you're a perfect coder. The first time you write it, it's going to model exactly what you want, the way you want to. There's no reason to check to make sure that your baseline actually matches a reasonable baseline. And most importantly, do not write documentation. This is just a giant waste of time. You're the only one that's going to use this tool, and you have a perfect memory. In 3 years from now, when your thesis committee asks you to run just one more experiment based on that tool you wrote, no problem remembering how to do that. No problem remembering how it works, etc. Okay, so let's say you've ignored what I said before, and instead of making an in-house tool, you've decided you're going to release it to the public. Well, what you should do is make the tool open source. And what does this mean? Well, one of the good qualities of an open source tool is forcing people to register before they can download your code. Everybody really loves filling out web forms and giving an email to yet another database. And then, once they've registered and are able to download the code, just give them a tarball. They don't need anything else. They don't need to see the version history or anything like that. And when you update it to the next version, just give them another tarball. They can figure out what the differences are themselves. Why would anybody need anything other than just the source and a bunch of C files? They'll figure out how to compile it. No big deal. And, don't put a license in there because clearly you own all the rights to the code, or it's open source, right? That means anybody can do anything they want with it. You don't need to tell people how to use their code. Or if you're going to provide a license, make sure to provide restrictive licenses. The GPL is great because it forces others to do with their code what you want them to do with it. You're telling them what to do with their code. Okay, a couple more to go. So don't market your tool. There's no need to come up with a good name for your tool. Think of a common English word like cat. Super easy to Google and find your tool. Or someone else came up with a good name, you should copy it. Chrome. That is a great name for a tool. Let's use that. Another thing you should always do is never create a web page. Domain names are expensive. It's a pain to set up a web page. It's really hard. Don't spend the time on that. And you don't need to provide any context beyond the paper anyway. Like a research paper, that is a great way to explain how to use a tool and what a tool is used for and how a tool was developed. People love having to go behind ACM and IEEE's paywall in order to figure out how to use some tool that you've created. And finally, stop supporting the tool. You've gotten your paper published. Who cares about the tool after that? You've gotten everything you need out of it. Since the paper is accepted, this means the tool is perfect, right? This means there's no bugs in the tool. If you do put your tool out there, make sure not to help other people. Again, you wrote a perfect tool. There can't be bugs, and all that documentation that you wrote, of course, that's perfectly clear. No one could ever have any questions. And one thing people really love is dead links. I just love it when I Google and I find the perfect link that's going to give me the answer to the question I'm asking. I click that link and it takes me to a 404 from 1995. Wonderful. Okay, so of course, those are all the things we should not be doing if we want to be developing good tools. So let's talk about what we should be doing. So do share your tool. If you want your tool to have impact, if you want people to build on top of it, if you want industry to use it, if you want to get citations, get your tool out there. Let other people use your tool and develop it. And I mean, even if it's a research idea, people will, be able to build on top of it more easily if your tool is out there and available. Make your tool open source, and I'll talk more about what this means in a moment. But this is really important to provide a really good open source foundation in order for people to contribute back. And market your tool. Do this everywhere you can. Have websites, run tutorials at conferences, write books, create videos, use Twitter, whatever you can do to get this tool out there and in people's minds, this will allow you to have more impact in both your tool and your research. So do follow software best practices. What you want to do in order to have impact is make it easy for other people to use your tool. And this means follow software engineering best practices. Use Git, use some kind of version control, use good design practices, build modular systems. Use agile development practices, make small changes over time instead of big dumps. Use things like code review so people can understand what it means to contribute, and these kinds of things. And this last one is kind of a personal pet peeve of mine that I tell people when they're developing software. And that's when you're choosing what tool to use to develop your tool. So like say picking a version control system or picking where you're going to host it. Choose the most popular thing. Because what you want is for people to come and help contribute and use your tool. And if you choose the things that most people already know, it'll be more likely that it'll be easier for them to contribute. So instead of picking the hot new language, pick something that everyone in the community knows, unless there's a really compelling reason to use some hot new language. And most importantly, support the tool over time. Again, if you want people to be building on top of your research ideas, if you want to have this impact, help others do this. Help others develop on your tool and use your tool. So provide documentation and support for your tool and continue development after the release. So I know these things are really hard, and in a moment I'll talk about maybe what we can do to make it easier for people to do these good practices. But before that, I want to talk in detail about a couple of these. All right, so first, it's really important to make the tool capital O, capital S, open source. And so what does this mean? This means including a license file with all distributions. So by providing a license file, you allow the people who are using your code to know what they're allowed to do with it. And this is particularly important for having impact in industry. So you should try to use, you should use an OSI approved license. And specifically, I would encourage you to use a more permissive license. Especially in industry, this is important. Industry lawyers only understand a few open source licenses, and they get real skittish when you use things like GPL, which restricts what people can do with it. So Apache licenses and BSD are good licenses, especially if you want to have impact in industry. And if you're doing things like writing documentation or putting open source teaching materials out there, I would encourage you to use things like the Creative Commons licenses. So another thing to think about, if you want your tool to have impact, especially over the long term, is as the project grows from a single grad student sitting in their office developing some research tool into something that's a true open source community, the leadership should grow as well. And so it's really important to have things like a governance document that defines processes within the community and set up a committee to manage the day-to-day things that are going on. Because, as you grow your community with more developers and more users, conflicts will arise. And if you set up processes ahead of time to deal with those conflicts, everything will go much smoother. And this last one is something that I've been thinking about recently in terms of, say, the Gem 5 development. Gem 5 has been around for quite a while. Something that's important to think about early on in the development of a tool is, what is your exit strategy? So if you don't think about, where the tool is going, what the tool is going to become in 5, 10, 15, maybe even 20 years, it's just going to kind of languish. You're going to stop working on the tool, or maybe someone's going to pick it up, but then they're going to stop working on the tool and it's going to stop being developed. And I'm sure a lot of tools, this is just what's going to happen over time. But thinking about what the exit strategy is, and some examples would be things like moving under an umbrella organization. So becoming part of the Linux Foundation or the Apache Foundation is one exit strategy for an open source tool or project. Other exit strategies would include having a startup that picks up the development and continues developing the tool, creating a nonprofit around the tool, or maybe even some big company like Google or Microsoft or Facebook taking ownership over the tool and then doing development from the companies. So another thing that's really important, especially to me, is creating a community around these tools. So again, if you want users, you want developers, you want to have impact, it's important to foster a community that works together in order to do this. And so some ways we can help foster a better community is by answering questions when they come up. So provide something like a mailing list or even GitHub issues or Slack or whatever it is in order to answer the questions as they come up. The other thing to do is to provide answers to questions before they arise. I know documentation is incredibly difficult. It takes a lot of time. It's really hard to write good documentation, but it's also really, really important. And write two kinds of documentation. Documentation both for developers who will contribute to your tool, as well as for users that will be using the tool. And there's a lot of really good tools out there now for this kind of thing, like Read the Docs. And finally, kind of going back to a little bit more structured approach, make sure you have a contributing document with your code that explains how to contribute. Both like users can contribute by asking and answering questions even. Setting up these kinds of things will make it easier. It'll flatten the learning curve in order to contribute to your project. And also it's really important to have a code of conduct. Because again, what you want to do to have impact is grow your community, and you want to make this community as inclusive and inviting as possible. The more people you can have in your community, the more impact there will be. And having things like a code of conduct makes a lot of people feel more comfortable coming into a project and contributing. Okay, but I hear all of you saying, but how do we do this, right? Like, the way the system is set up is not to encourage all of these good practices. It takes time and effort. And you're right, especially coming from industry or from academia, excuse me, the incentive structure really pushes us towards building these bad tools. We're incentivized to create in-house tools, for instance. We're incentivized not to write documentation. And that's because what do? We count papers. We don't count infrastructure when we're doing things. We have all these bean counters, not counting the fertile soil that we're working on. So what do I think we should do? Well, I think we should have more recognition for good tools and good infrastructure. So things like an infrastructure track. I would love to see an infrastructure track at ISCA or at ASPLOS, so it's focused on tools and infrastructure. I think we should have more awards. Yesterday on my Twitter feed, I noticed that this software engineering conference had an award for the best tool. There's no reason why we can't do that kind of thing in architecture and other systems fields. Artifact badges are a great start, but I think we can do even more. And if we have to count beans, maybe we can find some beans to count. We can count code commits, count code reviews, even questions answered on Stack Overflow. I'm not sure if any of these are actually good ideas, but there's ways we can try to develop a community that cares more about these kinds of things. So another problem we have is our funding structure. So we get funding for research, not for infrastructure. So if you think about a 3-year NSF grant, in your first year or two, you're developing infrastructure. In years 2 and 3, maybe you're actually publishing the papers, and then the grant ends, and there's no way, there's no funding method to continue working on that infrastructure that you developed in the first couple of years. Not to mention the people who did develop that infrastructure have moved on and are working on bigger and better things. So what I think we could do here is have more lab techs, like software developers who sit with our students and actually contribute to the software and help kind of smooth out things over time in developing these tools. And there are some good infrastructure development funding opportunities, but again, they're usually limited in time to a few years. And so finding a way to have some kind of continuing development funds, I think, is really important. Okay, so another way we can look at this is how have successful projects, things that I think personally believe have had big impact, what did they do? So if we look at these kinds of things like LLVM and RISC-V, I think are both really good examples, and Gem5 maybe a little bit of an anti-example. What do they have in common? Is that there's huge industry support. So if you take LLVM as an example, it was originally developed at UIUC, but then picked up by industry, and Apple which really pushed the development forward. And that's how it really grew to have big impact. RISC-V, similarly, it started at Berkeley as an academic project, but then through the RISC-V Foundation and a bunch of startups that were created based on RISC-V, that is what's grown it into being really big. Gem5, it hasn't had anywhere near the impact of these other two kinds of projects. And, maybe it's because we haven't been picked up by industry the way RISC-V and LLVM have. So another way to look at this is, so the Linux Foundation supports open source projects. What they say about how to build an open source project, which is a little bit different than a research project, is that sustainable projects have a developer community whose technology is used in commercial solutions that profit businesses, who then in turn reinvest back into the project, hire developers for it, etc. So you get this virtuous cycle between a good project being developed, industry picking it up, and then industry contributing back, because that project becomes a really key business proposition for that industry. So what about a virtuous cycle for research? We can kind of think about this in the same context. And, can we replace some of these words? Does it make sense for products to be papers, or profits to be funding? Maybe profits are papers. Is it that developer community whose technology is used in research projects to produce papers that then reinvest back into the project by hiring students? I don't know. It seems kind of, it doesn't seem to really work out this way. I'm not sure if this is the same kind of virtuous cycle that we can use to improve research tools. So maybe another way to look at it is that we need to intertwine our tools and our research. And I think this is something that, especially the systems, the OS systems community has done a really good job of. What if the tool development was the research? What if as you were developing your tool, you were doing the research? So instead of coming up with a research idea, then building a tool to evaluate it, it was about building the tool that generated this research. And then the research kind of requires the tool in order to be done. So can we build this like tightly interconnected mesh of research and tool, research and tool, research and tool? And this, we can even satisfy the bean counters maybe, especially if you have some kind of agile development philosophy where like you're developing the tool a little bit, then you have a new research idea and you can publish on that. Develop the tool a little bit more, you have a new research idea, you can publish on that. I think this might be closer to what we're thinking of, but I don't know. I'm still really struggling with this personally, and I would love to hear feedback from the broader community, especially those here that have had good success doing this kind of model. Because I think this is still really, really hard with the current incentives that we have. Okay, so let's get back down to earth here. I kind of started this talk about, what is a good research tool? A good research tool is one that generates impact. So let's think about this. Is the tool that you're developing the next LLVM? Probably not. But wouldn't it be really cool if it was? Isn't that the dream, to develop these really high impact tools? At least that's my dream. I would encourage all of you, whether or not your tool will be the next LLVM, to develop it like it's going to be, because this will help you have more impact. This will help you in your research. It will help the community and the community's research. It will help advance scientific progress, and it will increase the impact of your tool. So with that, I hope that I've shown you a little bit about, how not to develop a bad research tool, but how we can all develop great research tools. And with that, I hope that I have incensed the entire audience, and there's lots of angry questions coming at me.